This is chapter 9. We're going to start talking about chemical bonding. And we're going to do this in a couple of chapters. In this chapter, we talk about the Lewis model. Here's just a little introduction, which helps us to understand why bonding models are important. I think we've all heard of AIDS and HIV. Back in 1989, they determined the structure of HIV protease. That's a protein synthesized by the HIV virus. It's an enzyme that the virus uses in its reproduction. Researchers were able to design several different molecules that could disable that enzyme by binding to the active site. And one of the things that really helped them in designing these molecules was bonding theories that help us to predict and simulate the shapes of these potential drugs and determine how they would interact. You can do this, on a computer before you try to synthesize this molecule and see if it actually works. And so that helped. So these protease inhibitors don't cure HIV. Someone with HIV will still have HIV. But you can, by disabling this protease, you can reduce the viral levels to undetectable. And so the person will not have symptoms as long as they continue to take the medication. So this is a very practical use of bonding models in medicine. Bonding models, bonding theories explain how atoms join together to form molecules. Why, you can put two hydrogens and an oxygen together and that will be a stable molecule, but if you try to put a hydrogen and an oxygen together, that would not be a stable molecule. They also predict the shapes of the molecules, and the shape of a molecule has a big impact on its chemical and physical properties, so that's important. We have different bonding models, and there's a trade-off between predictive power and complexity. So you can have a very simple model like the Lewis model, easy to understand, but its ability to predict things is limited. It works in certain circumstances. You can have a very elaborate model that works for everything, but then it's really difficult to understand. So there's a trade-off. They're useful in different situations. So we're going to look at, first, the simple model, the Lewis model. This uses dots to represent the valence electrons. Valence electrons are really important because those are the ones that are involved in chemical bonds. So we draw what are called Lewis electron dot structures, or sometimes we just call them electron dot structures, to depict the molecules. So they're little pictures of molecules. It's very simple, enables us to do quick predictions, helps us to understand shape of molecules and whether these molecules are likely to be stable.